Welcome back to your Semester 2 final review. We're on to Problem 3, and we are looking to solve for x. Problem 2 is very similar to this. They both come from Lesson 6.5, and I'll remind you of the two steps that we're going to accomplish. Our first step is we need to make the bases, which are those big numbers, make the bases equal. Now, this problem is a little bit more challenging than Problem 2. And the reason it's more challenging is because they expect you to know some pretty big exponents here. But I'm going to assume that you don't know these big exponents and talk you through a couple different ways we can get to the answer. So the first thing I would try and do, if I'm looking at 256 to the x minus 1 equals 64 to the 2x minus 6, is I'd try to think, okay, we're going to change the bigger number into the smaller number. That is almost always what we're trying to do. So I would take that 256 and I would say, okay, what power of 64 equals 256? And I'd start with 64 to the first power, and I'm using your calculator notation, but you'll find that 64. And then I'd try 64 to the second power, and you're going to find that that's some absolutely giant number. And that's way too big. It's way bigger than 256. And so what that means then is that you're probably not going to be super successful doing 64 to a power or changing this into 64. So instead, we're going to have to change both of these numbers. And so when we change both of these numbers, I'm going to do 256 and 64. It's a bit of a guessing game. Now, if you look at these numbers, you might think, okay, well, I wonder if I can figure out a power, a nicer number, a smaller number that goes into both of them. For example, you might try 8 at first, because you're like, 8 goes into 64. I know that, right? It's not, so we know 8 to the second is 64, right? We write that as 8 squared. So we're like, okay, I wonder if I can change 256 into 8 as well. So you're like, well, let's try 8 to the third power. Oh, that's 512. We skipped right over 256, so I know it's not going to be 8. All right, so let's go smaller than 8, right? And you can go as small as you want. And again, I'm going to give you two different ways to do this, maybe even three different ways this time. But let's jump down to 4. Okay, so we might think, okay, let's try some powers of 4. So as you're working on your calculator, and I'm just going to shorten the notation, 4 squared is 16. That's not 64. 4 cubed, 4 times 4 times 4, that is 64. So we were able to rewrite 64 as a power of 4. Now we're going to say, well, I hope I can do 256 as a power of 4. We're going to start ahead of 4 cubed, so I'm going to try 4 to the fourth power. And lo and behold, when you do this on your calculator, this does end up being 256. And so one way that we could rewrite 64 and 256, and the way that I'm going to use, because I think it's a little bit easier, as 4 to the third and 4 to the fourth. So what's going to change here? Well, certainly not the exponents. We didn't touch those. However, the bases will change. 64 becomes 4 cubed. It's a different way to write 64. And 256 becomes 4 to the fourth. Now, if you didn't guess 4 and you tried a smaller number, right? And I'm guessing these nice even numbers here because we end in even numbers, so it's certainly not going to be 5 or probably not 3 or anything like that. You might have guessed 2. And 2 also works here. The powers of 2 are quite a bit bigger, though. So 2 to the third is 8, the fourth is 16, the fifth is 32, the sixth will get you 64. And then the seventh is 128th, and then the eighth ends up being 256. So you could have, instead of 4 cubed and 4 to the fourth, replaced it with 2 to the sixth and 2 to the eighth. I personally am not a fan of this problem, right? This comes from our district, because I don't like that they're making you use huge exponents here. I'm always a proponent or a fan of only using a third power or smaller. Should you know how to do it? Sure. But it just gets kind of tedious when you have to guess and check like this. So let's go ahead and finish this off. Before we get to step 2, I do like to simplify what we have here. I don't like to see different bases inside the parentheses. And so to simplify, notice that we have an exponent and another exponent separated by parentheses. And when we have that, when we have 4 parentheses x minus 1, we're going to go ahead and distribute. So that's going to give me 4 to the power of 4x minus 4. And on the other side, same thing. Distribute the 3. So we end up with 4 to the power of 6x minus 18. We have made the bases equal. Now it's time to focus on the exponents. So set the exponents equal. I think in my last video I said solve the exponents. Same idea though. So we're going to take our exponents. We're now done with the bases. We've made them equal. Now we just need to determine what makes the exponents equal. Like so. This is all about SADMAP, getting x by itself. Before we get x by itself, though, I always like to move the x's to the same side using addition and subtraction. And personal preference, I like to make them positive. So I'm going to subtract 4x from each side. This leaves me with negative 4 equals 2x minus 18. Once all the x's are grouped together, now it's just SADMAP. What's attached to x? 2 is multiplying, 18 is subtracting. So let's undo the addition or subtraction first. This leaves me with 18 minus 4, looks like 14, I think, equals 2x. And hopefully you can see that 2 times 7 is 14, but if not, you can follow this last step. 14 divided by 2 is 7, and it looks like 7 is x. Hopefully that's an answer at the top. Oh, good, it is. There is one more way to check this though, and this is what I covered in my last video, and that's really just by using your calculator to figure out each answer. However, something weird is going to happen with this one. Maybe not weird, but an uncomfortable feeling. So remember the 7, and I'm going to check 7 in for the x for 256. So we've got, I'll clear this out from our last one, 256 to the power of, and then looking here, it was x minus 1, right? So to the power of, parentheses, 7 minus 1. Look at this absolutely huge number. We might remember from science, 10 to the 14th means move the decimal 14 times to your right. Yeah, exponentials get really big really fast. But that is still the answer. And your calculator will do something similar. It might say like E14. It might do this 10 to the 14, something like that. But remember that number. I'm going to do the same thing over here. 64 to the 2 times 7 minus 6. 64 to the 2 times 7 minus 6. And notice we did get the same answer again. So these exponentials get real big, real fast. Don't let that throw you off. They are still the same answer. Thanks for tuning in, and hopefully you're finding some success on your final review.